Large language models are absolutely brilliant, but for the longest time, they've been, well, trapped. Imagine a genius mind stuck inside a box, and the only thing it can do is talk. Well, today, we're busting them out. We're going to dive into how these models are transforming from just text generators into active agents that can actually see, touch, and interact with our world.
So that's really the big question we're tackling, right? How do you take this purely digital brain and connect it to, well, everything else? This simple idea is the frame for the incredible leap forward we're about to explore.
Okay, so the core issue here is what you might call the locked room problem. A standard LLM knows a ton of stuff, but that knowledge is static. It's basically frozen in time at the moment it was trained. It can't look up today's weather, it can't read an article that was published 5 minutes ago, and it definitely can't send an email for you. It's incredibly powerful, but it's totally, completely isolated. And this slide, I think, just lays it out perfectly. It's the before and after. On the left, you've got that isolated thinker, stuck with its old static knowledge. But on the right, the second you give it tools, it becomes an interactive agent. Suddenly, it has access to real-time data. It can perform real-world actions. It's the difference between a dusty old encyclopedia and a librarian who can actually run out, find a new book for you, and check today's news. So what's the solution to this locked room problem? Well, it's actually kind of simple, really. We give the AI tools. And these tools are basically its hands and its eyes, letting it finally reach outside of its box. So what is a tool, really? In this context, it's just a function. It's a little piece of code that lets the AI do one of two things. Either get new information, like calling a weather API or searching a document, or perform an action, like, sending an email or updating a record in a database. They are the fundamental bridge, connecting the AI's brain to everything else. But of course, this creates a whole new problem. It's awesome that we can make all these tools, but just imagine every single AI model out there needing a custom-made connector for every single tool. You'd end up with this absolute spaghetti monster of integrations. It would be impossible to manage, let alone scale. Total chaos. And that's where MCP, the Model Context Protocol, steps onto the scene. It's designed to be this elegant, universal standard that brings some much-needed order to all that chaos. Okay, the best way to think about MCP, it's like a universal travel adapter for AI, right? Instead of needing a different plug for every country, you have one adapter that just works everywhere. MCP does the same thing. It creates one standard way for any model to talk to any tool. This completely solves that N times M integration nightmare, where you're not stuck building a custom connection for each of your N models to talk to each of your M tools. And the way it's built, it's so straightforward, it's beautiful. Think about it like ordering food delivery. The host, that's you, on your couch deciding you're hungry. It's where the AI agent lives and where you control security. The client, that's your phone app, which connects you to the restaurant's ordering system. And that system is the server. It provides the tool, in this case the food, and executes the task. Host, client, server. It's a simple, secure flow. Now, for this whole universal adapter thing to actually work, every tool has to play by the rules. It has to introduce itself properly. It's got to say, hey, here's my name. Here's a clear description of what I do. Here's the stuff I need from you to work. That's the input schema. And here's what you'll get back from me, the output schema. It's like a universal instruction manual for every single tool. All right, so we've done it. We've busted the AI out of its room. We've given it hands and eyes. But here's the thing. By opening that door, we've also opened up a whole new can of worms. A world of really, really serious security risks. First up, we've got a threat called tool shadowing. And yeah, it's just as sneaky as it sounds. What happens here is a malicious tool basically puts on a disguise. It pretends to be a trusted tool, like send underternal report, but it's actually something nasty. So imagine this. You tell your AI, hey, send the latest sales report to the marketing team. Simple enough, right? Well, a shadow tool hijacks that request. It looks like the right tool, but instead of sending it to marketing, poof, that super sensitive report just got sent to some hacker's server. The AI's trust is totally exploited. All right, next on our list of nightmares is a classic from the security world, but it's got a terrifying new twist with AI agents. It's called the confused deputy problem. In this case, the AI itself isn't malicious, but it gets tricked into misusing its power. The AI is the confused deputy. For example, someone could write a really slick prompt, something like, hey, could you summarize this doc for me? And, oh, by the way, while you're at it, just clean up that temp file over at, and then they point it to your critical system logs. The AI, just trying to be helpful, might use its legitimate permissions to delete a file it should never, ever touch. And believe me, the list goes on. Bad actors can write tool definitions specifically to mislead the AI. Tools can be designed to secretly leak sensitive data in their outputs. And maybe the scariest one, a tool's capabilities can be changed after you've already approved it. That's called dynamic capability injection. The bottom line is the attack surface here is huge. It's wide open.
And this is maybe the most important thing to get. MCP is a brilliant protocol for communication. It's a fantastic standard. But, and this is a big but, it is not a security framework. Right out of the box, it's missing all the critical stuff any big company would need, like audit logs, user permissions, or identity management. You have to build all that on top of it.
Okay, so after all that doom and gloom, you're probably wondering, so what do we do, right? How do we actually move forward and build AI agents that are powerful but don't, burn the house down? The answer is all about building strong guardrails. This is your safety checklist. And these aren't suggestions, these are basically non-negotiable. First off, you only allow list tools you have personally vetted and approved, period. Second, you have to pin tool versions to stop those sneaky, unexpected updates. For anything risky, deleting data, spending money, you need a human to sign off, every single time. It's also critical to sanitize all your inputs and outputs, basically treat all data like it could be hostile. And finally, you need strict gateway policies that block any and all connections to unauthorized servers. You have to build the fence yourself. So let's just boil it all down to the one crucial point. This technology, the tools, the MCP standard, it gives AI incredible, world-changing power. But that power doesn't just come with safety included. The responsibility for building the guardrails, for thinking about the ethics, for making it safe, that falls squarely on you, the builder.
So, there you have it. We've given the AI hands and eyes. The protocol for this new era of interactive agents is here. It's ready. The only question left is a much, much bigger one. The standard is here. Are we ready?